Okay, so in this tutorial we're going to use the Finch in order to tell us which numbers to switch in our array when we're doing sorting. We're going to use exactly the same code that you've learned in your Java tutorial. So if you import that code here, as you'll see, we have sorts and sort grades. So we've imported that code exactly as it is, and we've linked the two. The only code that we'll need to change is the sorts code. So if we go into our sorts code, the first thing that we need to add is, of course, the libraries. So we import on the top the Finch libraries to use our robot. Now, there are three sorting algorithms in here. We're going to have a look at the bubble sort, but you can do this with the other two. And your challenge actually for the week is to take the code that we learned in the bubble sort and to implement it into the other two algorithms. So if we go to the bubble sort, this is the code for your bubble sort. The first thing is to create the Finch object. So we create a Finch, we name it myFinch, and it's an object type Finch. So now we can manipulate the robot. Now what we need to do is whenever there's a switch happening, I want the robot to tell me which number switches with what other number. So in order to do that, I'm going to go after the switch has happened and we know what the switch numbers are there, and I'm going to go myFinch dot say something, and we're going to say to it switch numbers, and the first number that we need to switch is located in the numbers array, and specifically it's the one that's in min for minimum, so that one there. The second number that we want is located again in the numbers array. This time it's in scan, so it's the one there. So now the Finch robot will be able to tell us which two numbers we need to switch. And the whole idea is that when we have our post-it notes, so you should basically have some post-it notes down on your table now with the numbers in the array that we have, and this is located in your sort grades class. So if we go in here, these are the numbers. If you have them on the table exactly in the same way that they are here, then we'll use the Finch robot to tell us which two we're switching every time it does a pass. So let's go back to our code. Now there's one more thing that we need to do for this to work. Because the code will continue, as soon as the Finch will say something, it will continue the if statement and the for loop. And it won't have time, the Finch won't have time to stop talking before you do the next switch. What we're going to do is we're going to give it a command to kind of pause the program until it's finished talking, and then it can loop and tell us the other numbers. If you're not exactly sure what I'm talking about, try to run the code as it is now with the Finch, and you will understand. It will sound like something's really gone wrong with the robot. So in order to stop the program until the Finch has stopped talking and then continue, what we're going to do is, now copy these commands exactly, we're going to do a try. A try is basically saying to it, do this command, and if something goes wrong, catch the error, but don't break the program. Don't worry right this second if you don't understand why that is. It's just a sort of a safety for us, okay? So just go with it for now. The main command that you need to know is the one called thread.sleep. And inside we're going to give it something like 5 seconds. And what that does, it tells the program stop for about 5 seconds, because as the Finch is talking, or you're doing some switching with the post-it notes, it just gives you a bit of time and it doesn't interrupt the robot while it's talking to say something else. So if we don't give it that command, usually what's going to happen is going to say switch numbers X and Y, and then before it finishes saying that, because the program's so fast, it will start saying switch numbers and switching the next numbers and switching the next numbers, and you'll hear something very weird. So try thread.sleep and catch. Catch is basically what happens if there is a problem, and we don't actually want it to do anything if there is a problem. Also, catch needs an exception named EX. So all that does is just say, try doing this command. If there's a problem, then just catch that exception, but continue using the program. Don't break it and don't exit the program. It's not relevant. It won't break the program, so don't worry for now, but this is all that try and catch means. We can do things here like x.print stack trace. If you don't know what that does, don't worry. Again, you can look it up. It just gives you a way to trace what error is happening, because these aren't errors that a user is doing. It's programming errors, but it won't show at compile time. It won't actually flag errors like this. So if something breaks within the program, you don't want it to break. You want it to just keep going, but just register that there's an error. But don't worry, it won't for our program because it's a very simple code. So all we've done here is just say, as soon as a switch happens, the Finch needs to tell us what numbers are being switched, and then thread.sleep just gives it enough time for it to say it and for us to switch our post-it notes. So if we compile that, I've forgotten a plus there, let's compile that, and another plus there. This is what we spend most of our time doing. It's called debugging. Probably forgotten another one of these. There we go. And so this is the code that we need. So now what happens if we go back to our classes and we compile sort grades and we run that, then hopefully the Finch should tell us which numbers to switch. Let's give it a shot.
Switch numbers 94 and 69. Switch numbers 94 and 80. Switch numbers 97 and 85. Switch numbers 97 and 73. Switch numbers 97 and 91. Switch numbers 97 and 77. Switch numbers 97 and 85. Switch numbers 97 and 93. Switch numbers 89 and 69. Switch numbers 89 and 80. Switch numbers 94 and 85. Switch numbers 94 and 73. Switch numbers 94 and 91. Switch numbers 94 and 77. Switch numbers 94 and 85. Switch numbers 94 and 93. Switch numbers 89 and 85. Switch numbers 89 and 73. Switch numbers 91 and 77. Switch numbers 91 and 85. Switch numbers 85 and 73. Switch numbers 89 and 77. Switch numbers 89 and 85. Switch numbers 80 and 73. Switch numbers 85 and 77. Switch numbers 80 and 77.